Welcome to the next chapter in the Pragmatic REST APIs course, where we are going to talk about HateOS and change management. HateOS, or Hypermedia as the engine of application state, is one of the most important topics in a REST API. According to Roy Fielding's definition of what a REST API is, you cannot have a REST API without HateOS. Another very important topic for any kind of API, and especially a REST API, is evolving the API over time. Over the years, we have developed a few strategies for versioning our APIs, and some of them are more RESTful than others. We're going to discuss this in one of our upcoming lessons. Now let me do a quick walkthrough of what I'm going to cover as part of this chapter. We're going to introduce HateOS, Hypermedia as the engine of application state, and I will do my best to explain what it is and why it's so valuable for a REST API. Then we are going to cover how to implement HateOS inside of our DevHabit application. You will see that ASP.NET Core already supports some mechanisms for making HateOS simple, and we are going to build on top of that support to introduce HateOS inside of our REST API. Then I'm going to introduce you to content negotiation inside of our REST API and supporting custom media types inside of our DevHabit application. After that, we're going to have a discussion about API versioning, if it makes sense in the context of a REST API, and what are the different ways that you can approach API versioning that are popular in the real world. Lastly, we'll finish off with a discussion about API change management. I'll give you some practical guidance of when it makes sense to version your API and how to approach versioning and change management in a way that makes the most sense for a REST API. So that's what I have in store for this chapter. We have many interesting topics to cover, and we can move on to our next lesson, Hypermedia as the engine of application state. Welcome to our next lesson, where we are going to discuss Hypermedia as the engine of application state. You can't have a proper REST API without Hypermedia. We also talked about this when we were discussing the Richardson maturity model, which is a simple scale to grade the restfulness of an API. And on level 3 of the Richardson maturity model, we have Hypermedia, which makes it an important constraint when designing REST APIs. As part of this lesson, I want to introduce you to HateOS, discuss what an API looks like from a client's perspective, with and without HateOS, and my hope is that by the end of the lesson, you will understand, at least conceptually, why HateOS is so valuable. Now let's try to unpack HateOS, and I'm going to start with a quote from Roy Fielding. He says, "When I say hypertext, I mean the simultaneous presentation of information and controls such that the information becomes the affordance through which the user or automation obtains choices and selects actions." As with most of Fielding's quotes that you might see out there, his writing is very academic, so it's tough to comprehend what he actually means without spending a considerable amount of time on it. What I want you to take away from this is that when we return a representation from our REST API that also includes Hypermedia, this now becomes information that the client can use to obtain what are the possible next choices or actions to be taken on a given resource. And this simple concept introduces so many powerful ideas. Now, if you aren't a native English speaker, the word affordance might be new to you. Affordance means the characteristics or properties of an object, and in our case, a resource representation that suggests how it can be used. So this is what Hypermedia should allow for our API clients. By introducing support for Hypermedia inside of our API, we improve the evolvability and self-descriptiveness of the API. What makes our API evolvable with Hypermedia is that we can introduce additional Hypermedia links over time. This can be because of introducing new business rules or capabilities on the API, or because of changing business rules that we can reflect to the API consumers through Hypermedia. By including the Hypermedia links as part of the resource representations, we make the API self-descriptive. The client only needs to obtain the representation of a resource, and then based on the representation and the Hypermedia links, the client can decide what are the possible actions they can take to transition the system or the resource into its next state. Another way to look at this is that the Hypermedia drives the client behavior. It's no longer the client applications that need to code the specific behavior that we want to implement. Instead, they can rely on Hypermedia by inspecting the Hypermedia links that we return from the API to figure out what is the behavior that we need to support given the current representation of the resource. Now, I'm well aware that what I've been describing so far might be too abstract for some of you if you've never heard of Hypermedia before, so let's try to understand this from a simple example. Here's a representation of our habit resource, and this is what we are returning when we fetch the habit resource based on its identifier. This representation only gives the client enough details to know how to present this on the user interface, but it doesn't tell the client how to modify this resource, in other words, how to send an update request to the API. It also doesn't tell the client how to possibly delete this resource, how to archive it, or how to introduce additional tags on the habit. These are all operations that are supported by our API, and the current representation that we are returning doesn't contain any information about the behavior that's available for this resource. Which brings us to this important question: how does the client know what to do next? The short answer is the client simply doesn't know. Whoever is developing the client application will need to obtain knowledge about our API to be able to construct a request to send to our API. Let me illustrate this with an example. Let's say that the client wants to send a request for updating the habit. For example, we are exposing a put endpoint for archiving a habit, and then here's all of the information that the client needs to know in order to construct a valid request. First, they need to know that they should use the put HTTP method. Then they need to know the resource name, which is the habits, and they also need to know how to append the resource identifier that's returned in the response. Now, this is even more difficult if we support data shaping on this resource, like we do, and let's say that the ID field is omitted from the response and we only return a subset of the fields with data shaping. In this case, the client doesn't even have enough information to construct a valid URI. And then the client should also know that they need to append archive to the URI in order to construct the complete URI for this operation. Now, if we extrapolate this onto our entire API, you can see how much of the logic for working with a REST API can leak into the client application. So without Hypermedia, we end up developing API clients that need a lot of knowledge of our API contract. Over the years, we've developed many tools to mitigate this, like the OpenAPI specification, that can also be used to generate API clients that can directly integrate with our API. We'll discuss more about this in an upcoming lesson, but you have to understand that this also introduces a lot of coupling between our API clients and the current API contract. If we want to evolve the API contract, this is now much more difficult to do because a lot of the API client controls are baked in at design time. Let's say we want to introduce an additional rule inside of our API. Now, every new rule becomes a breaking change if we don't support Hypermedia. For example, if we change the query parameters inside of our GET endpoints, these are breaking changes for our API clients. Without modifying how the query parameters are constructed on the client side, the client won't be able to correctly integrate with our API. On the other hand, if we were to drive these values using Hypermedia, without the client having to know so much details, introducing breaking changes like that is almost opaque to the client. Another example is if some operations aren't supported on our API based on the current state of the resource. Without Hypermedia, business rules like that have to be hard-coded into our client applications. With Hypermedia, we can simply return a link when some operation is supported. And if that operation isn't supported for the current state of the resource, we can simply omit the Hypermedia link from the response. On the client side, we can inspect the Hypermedia links, and if the link for some operation isn't included in the responses, then we can simply not render it on the client side. The core message behind all this is that the API is harder to evolve without Hypermedia. Now let's see what changes when we introduce support for Hypermedia inside of our REST API. First, what do we need to start supporting Hypermedia in our APIs? This concept isn't so complicated. All we have to do is include Hypermedia links in our API responses. These Hypermedia links tell the client what they can do with the resource. This lets the client inspect the links that they get back in the response and make decisions at runtime instead of at design time when we are writing the code. Now let me show you some practical examples. Here's the same representation of our habit, with many of the properties omitted for brevity, and I also introduced an additional property in the response called the links. This is a collection of objects where each object represents one Hypermedia link. In this example, you can see a Hypermedia link with the rel field, which is short for relation, where the value of this field is self. This is the self-referencing hypermedia link, and it lets you know how to obtain the current resource. It's also useful to figure out what is the URI of the current resource that you are working with. Now in practice, the href field will contain a fully qualified URL, but I simplified it for this example. Now other than the self-referencing link, we can introduce as many of them as we want. For example, here's a link for archiving this habit, and it contains the fully qualified URL, even though it isn't fully qualified for this example, but bear with me. And if we send a request to this URL, we will perform the archiving operation. So this is a structure we will use in our API responses to describe hypermedia links. It contains three simple fields. The href, which contains a fully qualified URL where we can send our API request, the rel field, which defines the type of action that we can perform using the given hypermedia link, and then the method field will contain which HTTP method we should use with this request. So it's a simple data structure, but it opens up some very interesting capabilities inside of our REST API. Over the years, there have been many attempts at standardizing hypermedia in REST APIs. I will highlight some of the most popular contributions, with the first one being Siren. It's short for Structured Interface for Representing Entities, and it's essentially a hypermedia specification for representing your entities. You can see there haven't been any updates to Siren in years. Then another popular one is Hydra, hypermedia-driven web APIs. We also have JSON LD, JSON for linking data, and it's a data format that's based on JSON, but also introduced support for linking data, which should make it valuable for building REST APIs. Then we have HAL, Hypertext Application Language, which also hasn't been updated in many years, but this one's interesting because it contains its own media type. You can see an example here. There is a standard links property that should contain the available set of operations for a given resource. We also have JSON API, which is a specification for building APIs in JSON, and it also comes with its own recommended response structure, which of course contains hypermedia links as a standard property. We also have OData, which is a standard for building REST APIs, and it also covers URL conventions, querying APIs, and of course hypermedia. I will not be doing a deep dive into these specifications as part of this course, but I'm going to leave a link to all of them: Siren, Hydra, JSON LD, HAL, JSON API, and OData right under this video so that you can explore them on your own time. And I think that's enough theory when it comes to hypermedia. So let's move into some more practical lessons. In our next lesson, we'll be doing just a quick code refactoring, as our application has grown considerably from the first lesson, and we haven't been paying too much attention to proper code structure. So we're going to make some slight adjustments in the next lesson before continuing with HateOS.